A rare but useful use of subqueries is relational division. Relational division is the logical opposite of a cross-join. A cross-join is the Cartesian product of two data sets. So it's data set A times data set B produces a full Cartesian product. What relational division does is it says, well, we have the product and we know one of the source data sets, so we can figure out what the other data set was. It's just the opposite of a cross-join, opposite of relational multiplication. And before the theory gets so deep that we can't figure out a practical purpose, let me show you why you might want to know about relational division. The classic textbook example is figuring out which students have met all of their requirements for their major at a college curriculum. If you only do a join between requirement and students, you'll find every student who has taken at least one of the courses in their requirements list, and that's not very useful at all. You'd have to manually go through and figure it out. But relational division is able to say, find the set that completely works back so we have every requirement met, which is sometimes exactly the problem that needs to be solved. There was one time during a consulting job when a developer asked me how to solve, and he described the problem, and it was exactly relational division. And I said, oh, go look on page 384 or whatever it was in my book, and there's the code. Just take that code and figure out it's relational division. That's the kind of problem. A couple weeks later, I went into him and I said, hey, did that work for you? And he said, yeah, but he still didn't get it, and he'd solved it with cursors instead. So even though you run into relational division problems rarely, it's important to know this is the set-based manner that you can solve these kinds of problems. So let me go ahead and set up this problem first, then we'll walk through the queries that can do relational division. Switching to the OBX-Kites database, and let me just show you ahead of time before we run all of this. This is going to add some orders and add items to the orders. So we have enough customers who have ordered all of the toys. And what we're going to ask is we're going to say, which customers have ordered every toy that the OBX-Kites store sells? And then we can say, who has ordered all the toys and additional items as well? And that's the two ways of doing relational division, with remainder and without a remainder. So we'll set up the data. Executed successfully. This is just if you want to test and see yes is all the data there. So the first relational division query here is with remainder, meaning we're allowed to have other additional items ordered besides just toys. Or in the textbook example, it would find students who have taken every required course and possibly some other electives or other courses as well. So we're basically going to say, is the number of toys ordered equal to the number of toys available? And so this basically does a count, and some of this code references aggregate functions we're going to see in the next lesson. But the key is how the subqueries are being used. So it's saying, is the number of toys ordered equal to the number of toys available? And if so, return that customer. And we find 3 contact people who have ordered the exact number of toys, plus possibly other toys because we said with remainder. The more intense version of relational division finds the people who have ordered exactly every toy, but nothing else, no other kites, no other clothing, no other products. So it would find every student who has taken every required course, but no other electives. And that's considered exact relational division with no remainder. So the question we're going to say is the number of all products ordered equal to the number of toys ordered, and this subquery calculates the number of toys ordered, equal to the number of toys available, and the number of products ordered as well. So it has to go through quite a few steps to get it done. And those are the contacts who have ordered every toy but nothing else. And my expectation here is not that you're going to go, aha, I can dream in relational division. But I want you to know that this kind of solution is possible, so when you do run into it, you know where to come to find the answer. So subqueries, simple and correlated. Remember, a simple subquery you can simply highlight and execute because it can run by itself as a standalone query. Correlated subqueries are those that refer to the outer query. Simple subqueries are executed first, then the outer query. Correlated subqueries, the outer query is executed first, and then for every row of the outer query, the inner query or the subquery is executed. Subqueries can be used in many places throughout the outer query. They can be placed in an expression if it's a scalar. They can be used as derived tables. They can be used in the where clause using either the equals, the in, the not in, or the exists or where not exists. And then lastly, relational division. Pretty powerful stuff. SQL really is the Romance language of data and the best way to extract the data you want out of the database.